We found a dongle. Amazing. No. Thank you all so much for joining. We're going to get started right now, just because we're running a couple minutes late. We are so excited to have Pat McLean join us from ABInBev to talk to us today. So I'll hand it right over to you.
Hey, good morning. Thanks, New Relic, for letting us come and talk about how we use their product to monitor our micro front ends. So again, I'm Pat McLean. I'm the technical lead for store management tooling at ABInBev and Bees. And we're going to talk about micro front ends this morning. So really a high-level overview of what we're going to chat about. First is, what is Bees? Has anybody heard of Bees before? Yeah, all my coworkers raised their hands. Thanks, guys. How about ABInBev? Budweiser? Yes. Yeah. So we'll talk about what Bees is. It correlates with ABInBev because we are part of ABInBev. What is BeesHub, which is our micro front-end framework? How we utilize New Relic within that framework. How we added New Relic and observability onto our paved road for our developer users. And all of it ties into managing New Relic as code. That's the magic that makes all of this work. So we'll talk about how you can get started and experiment with managing your New Relic as code. So first, what is Bees? Since no one's heard of it, Bees is an e-commerce and SaaS company created by ABInBev. So it was originally an e-commerce application created for our points of consumption, so our bars, restaurants, grocery stores, to order products from us, manage deliveries, pay invoices. And for the majority of our users, this is what Bees looks like. It is a mobile application. You can order products, you can redeem your reward points, pay invoices. This is the experience. It's an e-commerce application. And today, it's live in 17 different markets. We have most of the Americas covered. We're expanding in Africa. We began our movement into Asia with China last year. And hopefully this year, we'll start moving the needle in Europe. Hopefully I was allowed to share that. If not, I'll get in trouble later. And thankfully, our senior leadership team is very proud of the work that we do, and they include statistics on our work in our quarterly reports. So it's not secret, I can share that with you. So our transactional volume in the first quarter of this year, we processed 23 million transactions for a gross merchandise value of over $6.5 billion. That's roughly $72 million worth of transactions daily. Usually it's a little higher than that because most of our transactions flow Monday through Friday. But we process a fair number of orders. And like any other e-commerce application, we have admin users those are our back office employees who are managing products, updating orders, and assisting our customers. And those users needed a place to do that work. And as we move from our original monolithic architecture into microservices, we needed to build out the corresponding front ends for those services and for those back office users. And that's where BeesHub was born. And again, it's the home of all of our back office applications. And we use a micro front-end architecture to align the applications or our micro front ends with their back-end services. So those teams can work very closely. But for our users, it's a single point of entry for every back office operation they need to do. Our users have no idea that BeesHub is split into currently 25 different micro front ends, because it doesn't matter to them. They don't care about our tech stack. They just need to get work done. But for our users, our developer users, we provide standards, designs. We call it the paved road. So we want to make things as easy for you as possible as a developer, but still giving you as much autonomy as you need to do your job. And these are screenshots of the initial designs for BeesHub. Again, it's a back office application. It's not the prettiest. We're working on updating it, but when you log in, you see a list of applications. It's tailored to your role. So if you have access to all of these applications, you see these tiles. If you only have access to PIM, you're just going to go straight to PIM. Right now, we have 25 different applications deployed in the hub. And again, that separation is transparent to the user. They don't know. It doesn't matter to them. The separation of those applications is really, it's dependent on our organizational structure. And all of those applications can be deployed and developed independently. So when you build a new application in BeesHub, you come to the core team who owns the portal. You let us know the route you would like to use for your application, the name of your application, and we add it to the hub. After that, your deployments, your development, the core team is no longer involved. Your team operates according to your team's needs and your users' needs. And what that looks like is the image on the bottom. We have a header that's persistent across all applications, but then that main content area, our application teams are free to do anything they like. For our user profile management, that's a single application. For our PIM application, they have 3 separate applications that mount in that content area, owned by different teams. And all of those applications can be developed and deployed anytime they want. So we use a paved road, we call it the paved road, right? So we want our teams to come on board and focus on business logic. So when they're developing a new application, we don't want 25 different teams building deployment pipelines from scratch. We don't want 25 different teams re-implementing observability or component libraries. We want to give you all the things that are common across all the applications so you can really focus on what your business users need and focus on business logic. And that brings us into how BeesHub is utilizing New Relic and some of our mistakes that we made as we went on our journey. So we use at Bees New Relic for all of our observability. We use the APM for our microservices. We use browser for any of our front ends, logging. So when we launched BeesHub, we knew we were going to integrate it with the browser and SPA agent. And that gives us the visibility into our core web vitals, error rates, AJAX requests, so we can see if any of the requests are returning non-200 responses. Again, we monitor payload size, because with it being a back office application, sometimes the teams might request more data than they probably need to display, increasing load on our backends. And this was great. So we could log in, and as the owners of the portal, we could see that we had issues with our largest contentful paint. We could see that our first input delay was fantastic, and we were very happy with that. But the problem that we had was our applications didn't have this visibility into their micro front ends. We could only see it at an aggregate level for the entire portal. And what we found very quickly when we implemented alerts and alert policies was that the alert policies weren't very actionable. So what our response looked like when we had an alert notification come in is it always required triage from someone on the core team because the alerts were global for the whole portal. So someone from the core team needed to take this example alert with our JavaScript error rate spiking. They would then need to run a query and try and see the routes that the errors are happening on and say, oh, okay, most of the routes have apiary in the name. The errors are happening in the apiary application. Let's engage that team to figure out what we can do. Well, everything that we've done in the hub was meant to scale so we can add in applications without adding more staff and developers to the team that manages the portal. So needing a human being who wasn't involved with the application development to do that initial triage was not going to scale. It was fine when we had 2 or 3 applications. But when we got to 15, it became very unmanageable. And it's not a fun task for the developer who needs to do that triage. And we're expensive, and we're hard to replace. So we want to keep our developers happy. So we sat down and we thought, how do we make this as easy as possible? And how do we, what do we want this to look like? And we can see Drake is one of our front-end developers. And he doesn't want to learn NERCL. He doesn't want to learn how to manage his dashboards and code. He's a good developer. He can copy and paste things very efficiently. We're all masters of copy and paste. Let's make Drake happy. So we knew what we wanted, right? We wanted to separate out the telemetry data that we're getting by application so our teams could easily find it. We wanted the same thing for our alerts. So once we have that data inside of the telemetry, then we can also extract that for alert policies. We knew we needed to bake it in using our new Relic as code solution where we use Terraform. And all the teams need dashboards. And we want those dashboards added into the paved road. So we don't want somebody with no New Relic experience logging in there for the first time, looking at the hundreds of services that we have in the APM, thousands once you add in all of the non-prod environments, and trying to figure this all out from scratch. It's painful. And then once they figure that out, now they have to go in and understand Terraform. And we don't just use Terraform, we use TerraGrunt on top of that. So now there's 3 tools potentially that this development team needs to ramp up with before they can even understand what their application is doing. So the first step was, how do we collect that? How do we, when an application is mounted, how do we tell New Relic that an application is mounted? What we used was the browser agents API to add a custom attribute. So our framework is built on a top-level router called single SPA. And all that does is when you navigate to a route, if there's an application associated with that route, single SPA loads it. It bootstraps it. There's 3 functions you have to implement as the contract. But then that application could be React, it could be Angular, it could be Vue. It could actually be static HTML. It doesn't matter. So and that framework fires an event that we can listen for. So now, well, when a new application is mounted, let's add a custom attribute called microfrontend name or MFE name, and we'll pass in that application name. And what that did is it allows us to use that MFE name attribute in our queries, which we've got an example of below there, where it's not as big as I would have liked on the screen. But this is for our apiary application. You can see the mix of users by country. And prior to adding this attribute, that data was not accessible. It was very difficult to get to. You needed to use some like matching based on the URL, which that can be hit or miss, and there's a lot of room for error there. So once we knew how to query what application is live, we needed to recreate the browser UI. We didn't want to lose that global view. We didn't want to lose the portal visibility into performance, but we still needed to separate it out by application. So we thought, hey, we can do that via dashboards. So we built a couple dashboards for teams, handed them over, and we were just doing this manually. Handed them over, got some feedback, it made some adjustments, and we settled on what is ultimately very similar to this layout. You get some core web vitals, AppDex for route changes, AppDex for page loads, JavaScript errors. And once we had that, we needed to build it out into our observability paved road. But we didn't want to duplicate it. And I don't know if you guys have ever made mistakes writing your NERCL queries, similar to the mistakes we make when we write SQL queries. Sometimes we get it wrong, and we find out later that the query we wrote isn't giving us good data. And what I didn't want, and what the team didn't want, is a copy and paste solution where everybody was taking our dashboard as code and copying the entire thing. So when the query that I originally wrote, or anyone could write, turns out to be bad, I didn't want to have to go in and update it 25 times and then accidentally miss one, and weeks, months later, maybe there's one or two teams that never got that update. Now they're looking at bad data. They're making decisions based on bad information. So if we make a mistake, we need it to be fixable. We need to fix it in only one place. Same thing for our alert policies. Kind of one Terraform template to rule them all. But there needed to be some configuration, because not all applications are the same. What is a response error for one microservice might not be considered a response error for another. So if you're looking for a coupon code and you get a 404, maybe you don't want that to show up in your error rate, or that maybe maybe you have an acceptable error rate that's higher than our defaults. So we wanted that to be configurable as much as possible. Which brings us into how we manage New Relic as code. Does anybody here use Terraform to manage their New Relic information? It's cool. I don't know if anybody has ever experienced it, but maybe you're looking at an alert policy, and last week it fired, and this week you're looking at a dashboard. The dashboard, your applications are not healthy looking at the dashboard, and you're trying to figure out, why didn't I get notified of this? Well, it was because Joe was looking at the alert policy, tinkering with the query last week, and accidentally saved it. There's no history of that. I can't go into version control and see the ticket of why Joe changed it, whether it was intentional or accidental. New Relic as code solves that. It lets us see the history of changes, the context for those changes, lets us utilize CI/CD workflows for applying those changes so we can do pre-release validation. Terraform has you can plan. So if you make a change in Terraform, Terraform will tell you what that change is going to do before you apply it. So you can validate that the intended result is the result. And it lets us restrict edits inside of the New Relic UI. So our users can't go in and edit alert policies. You can't go in and create alert policies. This is how we manage New Relic. And we utilize TerraGrunt on top of Terraform as a templating agent, for lack of a better term. So we can have a template for a dashboard and reuse it in multiple places, which was perfect for our use case. Because again, we don't want to have to figure out who's using the template or who had copied the template originally when we want to make adjustments or improvements to those dashboards or alert policies. And New Relic provides first-class support for Terraform. They maintain an open source Terraform provider. You can see the source code, you can contribute to it, you can open issues on GitHub, you can open issues with New Relic support, you can talk to the product owner who owns their Terraform provider. And if you haven't played with Terraform before, this is what a dashboard looks like. This is what a dashboard with a single widget looks like via Terraform. You have the template. So we pull in a resource, which is the New Relic 1 dashboard resource. You give it a name, and the name includes a handful of variables. We've got the dashboard title. Create a page, which also will pull in that dashboard title for the page, and then adding a widget. And, when you're adding a widget, whether it's a billboard, a line chart, you determine where that widget or line chart is going to display on your page, and then the query. And Terraform provides some text formatting, and so for our micro front-end names down towards the bottom, you see we ingest that as an array of application names, and then we format it into our query. Which means for applications like our product management, who or teams like our product management who have 3, 4 applications, they can consolidate those into a single view. So the teams that own the individual applications can have a dashboard that gives them insights into their application, but then their engineering manager or coordinator who is across all of the applications can do the same for their entire team. And this is ultimately what we wound up with. This is the TerraGrunt configuration that will output the dashboards that we saw on the previous slide. Most of this is boilerplate too. So when you paste this in, the only items you care about are the dashboard title, so give your dashboard a name, and the microfrontend names. So tell us, what applications do you want to monitor with your dashboard? Same with alert policies, but the alert policies aren't as cool when you visualize them as a demo, so we're just going to pretend those aren't here. And any additional configurations for your widgets. So we expose variables that allow you to control when warnings and criticals happen for your billboard widgets. You can define these, or you can use the defaults. It's up to the team. So what does this look like? I know we talked about what it was previously. So if you have no experience with New Relic, no experience with Terraform, you needed to learn those things before you could start this process. With our templates and adding it into the paved road, we clone our repository, we go in, we need to create a directory with our application name. So we're going to create a dashboard for our price admin application. And we create a single file. And what we're all good at is pasting in a template. The template pulls in the Terraform module that we've created for the dashboard. And now what we need to do is give our dashboard a name. So we're going to name this dashboard price admin. And then we need to define the applications the dashboard will monitor. For this dashboard, it's just the price admin application. Now, for our setup, we need to explicitly add this for each of the environments. So we wanted to put this dashboard for our UAT environment, so we add the dashboard name to our UAT list. And once that's done, now we can create a dashboard. And that's it. For the demo, I'm running the command locally, but our CI/CD pipeline would generally do this on merge. And I will admit, there's a little bit of movie magic here. We sped this up. It takes about 2.5 minutes to run. But this is the output. I copy and pasted. I changed 2 lines. I ran a command, which normally you just merge a PR. And the output is, I see that I have a dashboard named UAT Hub Price Admin, and then the URL for that dashboard. So if we open up the dashboard, this application actually had no telemetry data, but the dashboard's there. So that removes that ramp up time. You can do this. All you need to know is how to use how to use Git, how to open a pull request, and get an approval. And you have a dashboard in 2 minutes. And this, we treat as almost a gateway drug. Because when you initially go into New Relic, there's a lot of data. And if you're not familiar with it, it's hard to know where to start. This gives you a starting point. So that time the developer used to spend learning New Relic, trying to figure out where to start, learning Terraform, now they can spend exploring. They can look at the queries that are in the dashboard. They can see how we're pulling data that's relevant to them, and they can be curious and explore, and they have a good starting point. And so that time we used to spend with that ramp up, now we can spend learning and doing things that are actually creating value instead of a one-time task that someone's going to struggle with and never going to have to do again. That's not a good thing for our developers to be spending time on. find my way back to that slide real quick. So for updating a dashboard, the experience is very similar. So this is our UAT dashboard for the suite of PIM applications. So AppDex looks okay. There's not a lot of traffic. Our core web vitals are all green, but we want to improve our largest contentful paint. So we want to decrease that threshold. So let's move the bar. So we can open up this widget. We can take a look. We'll edit it. We can see the query that's happening, how the application names are passed in, and those current thresholds. To update it, we hop into our TerraGrunt configuration file. We change the variables for the warn and critical thresholds. We apply those changes via Terraform. And again, this is usually just a matter of merging a pull request. Most of our developers don't set this up or run these commands locally. And it updates. Let me go back and take a look, because when we actually see, Terraform's letting us know what it did. So applying our changes was complete. We didn't add anything new, but we updated. So it tells us we made a change. If we were to scroll further up, it would tell us exactly what that change was, and then gives us the output. And then we check out our dashboard, and now we can see our largest contentful paint widget is red. So and our warning and critical thresholds are updated. And we didn't only do this for dashboards. We did it for alert policies. And it had a very positive impact on how we manage incidents inside of the hub and how our operations team interacts with the application teams. So before, remember, all of these applications in the hub, the separation is transparent to the user. Well, that created a problem. Our operations team was going in and they would log in. It doesn't look like it's multiple applications. So a lot of people make an assumption that the team that owns the portal owns all the applications in the portal, when nothing could be farther from the truth. Sometimes we don't know what an application inside of the hub does, because again, we just register a new application and then that team is free to build whatever they need to build. So looking at the response before, an alert would go off or a user would report an issue, and our operations team would contact the hub framework team. Maybe it takes 10 minutes for somebody to respond. Next, the hub team needs to identify which application triggered the alert. So now maybe that responder is familiar with Nurgle, maybe they're not. That takes some time. There's a learning curve there. So that team member needs to go in, they need to build a query that tells them which routes are causing our issue, and then go back into the portal configuration and determine which application is mounted on that route, and then they need to go find the team that owns that application. The best case scenario, that takes 10 minutes. And we then get a hold of the application owner to start responding to the alert. Now we're at another 10 minutes. Now we've done absolutely nothing other than busy work. So we spent 30 minutes trying to just figure out who's going to look at the issue. So it's 30 minutes where the user is suffering. The application is not behaving correctly, and we've done nothing but just get the right person on the call. Once we were able to see the applications with that telemetry data, we could have alerts that were specific for the application. So after this change, we have alerts that are specific to the application or those application teams. The alerts have runbooks that are built and written by the application teams. So if we get a high JavaScript error rate for our promotions administrative tool, the runbook associated with that alert is relevant to the promotions admin tool. And our operations team can go through that runbook immediately. Open it up, go start applying, doing whatever's in the runbook, and if it works, great, we've solved the problem. If not, well, the operations team looks at the runbook, who do I call? Cell phone numbers, Slack handles, right there. Now we've got our incident response almost instant. We're doing things that are providing value, resolving alerts. Worst case scenario, we're waiting a few minutes to get the right people on the phone. And what it does is it removes the hub framework as the bottleneck. So we don't have to have a developer doing the triage, figuring out who's the right person to get on the call. And then it allows the portal to scale up, and we can add exponential number of applications without having to add staff to help triage when things go wrong in those applications. But we really want to enhance it further. So that right now, if you look at those dashboard configurations in Terraform, you have the ability to customize your warn and critical thresholds, but you don't have the ability to add additional data. You can't consolidate that dashboard for your front end with a back end that's providing the data and have that view all in one place today. So we'd love to add that in the future. And then we've automated our application generation. So when new applications onboard into the hub, they run an Azure pipeline that creates the repo for them. It creates the microservice configuration that they need inside of Kubernetes. And it provides a template that gets an application up and running and configures it. Maybe within an hour, you can have a new application that says hello world inside of all the way up to production with very minimal effort. We want to include these dashboards and alert policies in that generation. So right now, it's an opt-in. Most teams do, because it's very easy to get started, but we want this to be automatic. Same thing with our runbook templates. You know, a lot of times we have very similar issues. The actions that you take for those issues are very similar. We can generate those runbooks via a template in most cases, and you just fill in the blanks. And talking to some of the new Relic team, even this week, they're very curious about how they can structure their Terraform provider and those Terraform resources in a way that will allow us to do this. So right now there is some technical limitations inside the Terraform provider holding us back, but we have buy-in from a great partner who's willing to work with us on that. And lastly, we want to create workflows that do alerts based on the policy metadata. So for the hub framework, if we have one application that's creating an issue or is experiencing an issue, that issue is very probably isolated to that application. Maybe they deployed something, maybe the backend broke the service contract. It's not a systemic problem. With the metadata, with the policies and utilizing the workflow tools, we can then look for multiple alerts being triggered across our portal. So if there's 5 applications that are in alert state, that's a good indicator that we may have a systemic issue. And instead of running 5 separate incidents with 5 separate incident managers across war rooms, we can proactively say, hey, this is very likely an issue with the framework or the portal itself. Let's put everybody in a single room and let's solve this together. So if there's anything that I hope you take out of this talk today, it's that you should manage New Relic as code. It's extremely powerful and it's easy to get started. So one of the things that I created, and there's a link on this slide, is just a boilerplate starter so you can experiment with this. Using Terraform and GitHub Actions. So you can clone the repo. You do need to create a Terraform cloud account because Terraform manages the state of the changes that you've made and the resources that you manage via Terraform to understand what changes would be applied when you're planning or applying them. But the template provides a starter pack. So you can create a pull request. That pull request will lint and plan your Terraform changes, let you know what will happen when you merge the pull request. And then with your primary branch, when you merge changes in there, whether it's via pull request or just pushing changes up, it will apply them and let you see them inside of New Relic. And like everybody else, we're hiring. So if you have any interest in working on problems like these or building a large-scale e-commerce platform to help sell beer to the world, come talk to us. There's a bunch of us floating around. So just wanted to take some time, open up. Are there any questions or anybody want to dig in further to any point?
I was just curious as to what level your dashboards kind of influence your product roadmap and what you're working on sprint to sprint and improving those and things like that.
Yeah, I think one of the key insights, let me see if I've got one of the dashboards up. Yeah, I'm not sure I have one with decent data right now, accessible. But one of the things that we've done is those dashboards include, and it gives teams access to how frequently users are navigating to pages. So we do have, we track analytics via segment, but the coverage is a little spotty for certain products and applications inside the hub. But this, being able to look at the request history, see the frequency of users landing on pages, really tells us if when we roll out a new feature, did we communicate it well? Did that feature add value? And then dictates where future enhancements to that feature may live on the roadmap going forward. I think our apiary team, which is an application used mostly by our operations to view potential issues inside of our catalog and other store services, you rolled out a feature where you could see invoices, and they saw, after they rolled that out, they saw a lot of traffic to the routes associated with that feature, and were able to prioritize future enhancements for that page and really communicate with our operations team and say, hey, you guys are using this a lot since we rolled it out. What do you like about it? What can we do to make it better? Yeah.
Great job. I loved it. There was one question I wanted to know is how are you managing exception handling from like the client side? Are you using error inbox? How are you handling that?
So one of the things, some of the features we don't have a good user story for how this integrates with. So the error inbox winds up being at the global portal level, so it's not as useful as we would like it to be. We're still trying to figure that out. Inside the error handling, so we deploy what we call shared services for common things our application teams use, so logging being one of those. So we have a logger service that integrates with the browser agent, and then so when you catch an exception and you use our logger service and log an error, that will show up in your error rate inside your dashboard, and then you can drill in and see details on that. Yeah.
Right now, in our case, like it says single application is Angular, and we started migrating towards the microfrontend on the end.
Sorry, I'm having a hard time hearing you.
Got a mic for you. Oh, sorry. Very loud mic for you.
Right now, we have Angular application as a single page, and we started our journey to migrate the microfrontend on React. So my question is, like, from your learnings, it'll be good to implement the New Relic in a global way and manage in the dashboards, or implement New Relic in each and every microfrontend component as a separate application.
So we did start down that path. One of our concerns was what would happen if we included multiple instances of the browser agent inside a single browser window, and the risk that posed. We didn't want to learn that it didn't work in production, and then the lift to implement it was a lot heavier than what you saw on the screen. It was 15 lines of code, tagged all the telemetry with the application data, so that the risk of doing that was a little bit less. The implementation effort, I would have loved to experiment with running multiple browser agents, but ultimately I do like having the global visibility into that data that we would have lost had we done the implementation with multiple entities or multiple browser agents running. Yeah.
So again, it seems that you're creating heavy UAT dashboards. So I'm guessing, you wrote the foundational part of your pre-prod development lifecycle work. And then you mentioned wanting to verify the changes when you improve, the less simple things that nature. How involved are your QA and QC teams in, that role as well? And are they, adding value and participating in leveraging new Relic with developers, and what does that whole process look like as far as fees and services?
I know at least within the hub and within the store management group, we treat UAT or pre-prod very similar to production. So the alerts, every alert that's in production, we have the same alert that's running in UAT. If we trip that in UAT, we treat it as seriously as we would if it went off in production, at least during business hours. And we're not going to wake anybody up after hours because UAT is acting funky. But our QAs, they do help triage some of those issues. And then they're very active writing synthetic monitors as well. So it's maybe not so much the dashboards and alert policies for our QAs. They're primarily using synthetics.
I guess one more follow-up question. Leveraging the data that you guys are getting, are you using it in the change management process? So you have all these nice, cool, standardized dashboards. Are you linking to those in your change management, adding in making it easy so that your change managers can just go and look at your tests from what you were doing in UAT during the time of new deployment being tested? It all looks good. Continue working good with the cap. So
Not yet, but it is something we have on the radar, and we do add to the roadmap. For our backend services at Bees, we do that. We haven't built out the capability to do some of the deployment tagging and some of the other metrics that we have on the back ends for our front end stack yet. It's not quite as mature, but we're getting there. Oh, sorry.
Yeah, I just looked at the first kind of tentpole pane. So you're running single spot as like a container application. So do you only get those metrics if something hits a route or sub-application directly?
Yes.
Okay.
Yeah.
So they navigate to a sub-application and I can get that first kind of tentpole pane metric?
No. So that is like all the page view timing metrics that you get on a hard refresh, you don't get those as you switch in between the applications. One of the things I'd love to do in the future, and we're still experimenting with how we'd implement it, is doing custom metrics. So when we're trying to find a good event to hook into before that mount happens, so we can do some timing measurements of how long that takes. So we can see the route change once you're inside the application, and those are really fast. When the route change takes longer, it kind of implies that you are switching between applications because there's that overhead of the initial load of the JavaScript assets, but there's no easy way to see that right now.
Cool. Thanks.
Yeah.
How do you manage with your QA team the use of synthetics versus just automation?
So a lot of it's really more of a monitoring. So we use synthetics for monitoring things we want alerts to trip for, and then we'll use testing frameworks like Robot or whatever the QA team is most comfortable with to do the end-to-end unit tests and those implementations. So most of the testing that we do is not using synthetics, but as we want to monitor critical path or critical use cases, we build those out in synthetics so we can alert on them. So if login or single sign-on breaks, we have synthetics that are monitoring that in non-prod and production. So if we push a change, we can alert. But doing the flow of, can I upload a product image inside of PIM, that would be outside of the scope of our normal synthetics use. What was that, Chris?
It's a partnership we have that we're delving into around being able to do, in testing and leveraging an existing partnership and basically using what you can see in browser to natively have that partnership integration with a load testing solution. So
Very nice.
it's out there, it's available, so we can have a conversation.
Any further questions? Well, thank you, Pat, so much. It's just been enough.
Thanks, everybody.
Again, just such a pleasure having you here. If you all have more technical questions, please feel free to stop by the demo booths in the flow. Those will be open through lunch, but not afterwards, so please be sure to stop by there promptly. If you stop by the log station, you'll see that you get a 30-day free trial of logs if you have not ingested any data within the last 30 days. And we also have free training courses as well. And don't forget the survey for the sessions in the app. We'd love to see your feedback.